Hello, Professor Lohman. This is test 2, question 9, part A. This is going to be a long one because it's question 2, but hold on and we'll get through it part by part. So we're starting with part A. So I will draw a picture and I'll read the question. You throw a ball straight up from the edge of a cliff. It leaves your hand moving at 12 meters per second. It's velocity initial. Air resistance can be neglected. Take the positive y direction to be upward and choose y equals 0 to be the point where the ball leaves your hand. So y naught equals 0. Find the ball's position at 0.3 seconds after it leaves your hands. T equals 0.3 seconds. Acceleration equals negative 9.8. Okay, now let's start the question. We can use the equation y equals y naught plus vt plus 1/2 at squared. Okay, we know y naught is 0. We know v naught is 12. 0.3 seconds. Negative 9.8 over 2. 0.3 squared. Okay, now I'll plug that into my calculator and see what I get. 12 times 0.3. Minus 9.8 over 2 times 0.3 squared. 3.15. 3.15. Okay. So now we'll move on to part B. That was correct. Okay, state whether the ball is above or below your hand 0.3 seconds. So we just found what y was at 0.3 seconds, and it's positive. So we know the ball is above your hand. Okay. Part C, find the y component of the ball's velocity 0.3 seconds after it leaves your hand. Okay, above, and we'll go to C. Okay, we're going to use the formula V equals V naught plus AT. Okay. So we know that B is 12, and we have negative 9.8. T is 0.3. Plug that in, and we'll get that V is equal to, hold on, 12 minus 9.8 times 0.3, 9.06. And that's correct. State whether the ball is moving upward. Part D, state whether the ball is moving upward or downward 0.3 seconds after it leaves your hand. So the ball is moving upward because we just found the velocity for 0.3 seconds, and it's positive, so we know that the ball is moving upward in the positive direction. Okay, find the ball's position 2.6 after it leaves your hand. Okay, so part D is upward, like we just explained. And part E, now we'll move on. We'll find the position. We're just going to plug it back into the equation we did in the above problem right up here. We're going to use the y naught plus vt plus 1/2 at squared equation. And we're going to plug 2.6 seconds into that equation. So 0 plus 12 2.6 minus 9.8 to 2.6 squared. Okay, plug that into the calculator. 12 times 2.6 minus 9.8 divided by 2 times 2.6 squared. That equals, y equals negative 1.924. Okay, now part F states, state whether the ball is above or below your hand 2.6 seconds after it leaves your hand. So it's that we just found that the answer to at 2.6 seconds is negative. We got a negative y, so the ball is below your hand. Part G, find the y component of the ball's velocity 2.6 after it leaves your hand. Okay, so we're gonna use this equation right here that we use for part C, except we're gonna plug in 2.6 seconds instead of 0.3 seconds. Okay, so part G equals to, we had 12 V equals 12 minus 9.8 times 2.6. Plug that into the calculator. 12 minus 9.8 times 2.6. We get V is equal to negative 13.49, and that's correct. Now we'll go to part H. State whether the ball is moving upward or downward 2.6 seconds after it leaves your hand. So the ball is moving downward because we just found that the velocity is negative 13.49, so it's moving in the negative direction. So the ball is moving downward. Now we get to part I. Okay, part I will draw a picture as I read the question. Okay, you throw a stone straight down from the top of a tall tower. Okay, person, tall tower, throw a ball straight down. It leaves your hand moving at 8 meters per second. So velocity initial equals 8 meters per second. And by the way, I didn't state this, but part A was meters and meters. Part C was in meters per second squared. No, meter per second, sorry. Part G was in meters per second, sorry. Part E was in meters. Just to get our units down. Sorry about that. Now we'll go back to part I. I'm trying to run through this problem, so I hopefully nothing cuts out for time reasons, because this video might be too long and my memory might run out, so I'm trying to go through it quickly. Now let's get back to part I. Air resistance can be neglected. Take the positive y direction to be upward and choose y equals 0 to be the point where the stone leaves your hand. Find the stone's position 1.5 seconds after it leaves your hand. Okay, so t equals 1.5 and y initial equals 0. Okay, we're looking for the stone's position, y, and we know acceleration equals negative 9.8. Okay, so now we can use the equation y equals y naught plus vt plus 1/2 at squared. We will find that y naught equals 0. The velocity is actually negative because it's falling down, so it's a -8. -8 per 1.5 times 1.5, -9.8 over 2, 1.5 squared. Okay, I'll just plug in this into my calculator, and we'll see what we get. Okay, I got -23. Y is equal to -23.025, and that is in meters. This is a y. Okay, that's correct. Now we'll go to part J. Find the y component of the stone's velocity 1.5 seconds after it leaves your hand. Okay, the y component for the stone's velocity 1.5 seconds. So we'll use the equation part J. We'll put a J here. We use the equation V equals V naught plus AT. Okay, we know that V is equal to -8 minus 9.8 and 1.5. Okay, we found that. We can plug that into the calculator now. -8 minus 9.8 times 1.5. -22.7 is the answer, and that's correct. Okay, meters per second. Okay, so now we go to part K. Okay, it says find the y component of the stone's velocity when it is 8 meters below your hand. Okay, so in order to find the y component, we're going to first find the time when it equals 8 meters per second. So we're going to find -8 equals 0 plus -8 t minus 9.8 t 9.8 over 2 t squared. Now we can plug this into the calculator to find the answer, or we can graph it, and I find that graphing it is actually much simpler, and you can find where it intersects the x-axis, and that will be the t that we're looking for. So let me plug this into the calculator. 8 minus okay, hold on. We'll plug this into the calculator right now. Okay, so it's 8 minus 8x minus 9.8 divided by 2x squared. Okay, we see that here's the graph, and at 0.7 it intersects the x-axis, so t is going to equal 0.7. Okay, now we have to plug 0.7 because we're finding the y component of the stone's velocity, so we can plug 0.7 back into the equation, and we will get -8 minus 9.8 times 0.7. Okay, and let me type that in. -8 minus 9.8 times 0.7. -14.9. 14.9 meters per second. That's correct. Now, let's look at part L. You throw a football straight up. I'll draw a picture and I'll put the camera to it in a minute. When the football is I'll show me doing the picture. When the football is 4 meters above where you left it, so y equals 4. When it left your hand, it moves upward at 0.5 meters per second. So velocity equals 0.5. What was the speed of the football when it left your hand? Okay, so we're looking for v naught. Okay, and y naught equals 0. Okay, so we can use the equation v squared equals v naught squared plus 2a 2a y minus y naught. Okay, so you know that the velocity is 0.5 squared. We'll be solving for v naught minus 2 times 9.8 and then y, and then there's going to be times 4. Okay, now I'll plug this into my calculator, do a little math. 0.5 squared -2 times 9.8 times 4 Okay. Okay, then I gotta do the square root. I'm doing the question right here. The answer. Enter. Okay, so the v naught is equal to 8.87 roughly. Okay, now part M. How much time elapses when the football leaves your hand until it is 4 meters above your hand? Okay, so we're gonna have to use the equation y equals y naught y naught plus v naught t plus 1/2 at squared. Okay, we found v naught. we found it to be 8.87. T, we're going to find it whenever it equals 4 meters above your hand. So y equals 4, and we have negative 9.8 over 2 t squared. So we're going to solve for t in this equation. I find it easier to graph it. So here I go. Negative 4. Hold on. Okay. Negative 4 plus 8.87 x minus 9.8 over 2 x squared. Okay. Okay. Okay, I've graphed it, and you can see where it intersects the where it intersects the x-axis. It is 0.85, so t is equal to 0.85. Yeah. Okay. Now we'll go to part N and finish this up. Okay. Part N says you throw a tennis ball straight up. Air resistance can be neglected. The maximum height above your hand that the ball reaches is h. Y equals h. At what speed does the ball leave your hand? We're looking for the velocity initial. Express your answer in terms of acceleration due to gravity and the variable h. So we're looking for v naught. We know y naught equals 0. And yeah, so we can use the equation. So here's what I have right here, right so far. Y equals h, y naught equals 0, and v naught is what we're solving for. Okay, so in order to solve for one last thing is the maximum at v should be equal to 0 at the maximum. So because that height y equals h is at a maximum height. So we can use the equation v squared equals v naught squared plus 2 acceleration y minus y naught. Okay, so we can just plug the stuff in. We know that equals 0. We have v naught squared minus 2g gravitational constant, h, then we have h minus 0. Okay, so we have negative 2gh equal to negative v naught squared. Divide by -1 to cancel out the negative. And then it'll just be v naught is equal to the square root of 2gh. Okay, we can see that that is right. It's the right answer. So now we'll go to part O. What is the speed of the ball when it is the height of h over 2 above your head? Okay, so go to O right up here. Have a space to write it. Okay, we'll use the same equation that we used in the previous problem. We'll use v squared equals v naught plus 2a y minus y naught. V naught squared. So we have v naught squared minus 2g h over 2 minus 0 equals v squared. So we have v squared equals to v naught squared minus 2g h over 2. We're going to find the square. Hello, Professor Lohman, we're back. The video cut out because there was not enough space, so it was too long, so I have to split this up into 2 parts. So we were just about to finish the last question, and I also noticed that that on the previous questions we were on part L. We didn't put the units to the question. So let me just do that for us right now. We're going to put meters per second for part L. Time is in seconds. And then this is in terms of U. V will be meters per second too, but we don't need to worry about that. Okay, so where we left off here, we were just about to we were on part O, and we were solving for the velocity. So we got right here where we were going to square root each side of the equation, and first we need to find something. We need to find what h equals and substitute for h. So we know that v naught equals root 2gh 2gh. So we go v naught squared equals 2gh v naught squared equals 2, so that's what h equals. So we can plug that back into the equation above here, and we'll have this equal to v squared minus 2g, and h is equal to v naught squared over 2g. V naught squared over 4g. Now we can cancel the g's, cancel the 2, so it would just be v naught squared minus v naught squared over 2, which is going to equal 1/2 v naught squared. which equals 1/2 V naught, which is the answer. Okay, we're on the final part now, part P. Okay, at what height above your hand is the speed of the ball half as great as when it left your hand? At what height above your hand? Sorry again, my video cut out once again. So here we are at part P, I mean. And we're going to find out the height above your hand when the speed of the ball is half as great as it was when it left your hand. So we're going to use the same formula that we've been using with V squared equals V naught squared plus 2A T final minus T initial, and you will see what we get. Okay, 2GH .5 squared is just 0.25. Oh, this is V naught equals 0.25 V naught. Okay. Oh, hold on. No, this is all. Yeah, there we go. So we'll have V naught squared over 4. Okay, then we can substitute V naught. We know V naught is root 2GH, so it'll be 2GH over 4 equals 2GH minus 2G lowercase h. Then we subtract from 1/2, and that will equal 0.75 GH, because this is 1/2. 1/2 minus 2 is 1.5 over 2. Oh wait, no, we divide by 2. No, we subtract. It'll be negative. So we'll have a negative 1.5. Hold on. We'll have 1.5 over 2 GH. It'll be negative, and then that will equal negative 2GH. Then divide by the negative 2 to both sides, negative 2G. Cancel out the G's. Then we just have H equals, let me see what we got here. 0.5 divided by 2. Yeah, it looks like I skipped a step. Sorry, it's just 1.5, and then we divide it by the 2. We already divided by the 2. So it'll be negative 2g. And that's going to equal 0.75 h. And that's the answer. And that would be meters if we got a unit. Thank you for your time. This has been my test 2 problem number 9.